Welcome everyone, my name is Abelardo Pardo and I work at the University of South Australia in Adelaide, Australia. I'm very happy to be able to talk to you in this Apereo conference and explain the ideas and the structure behind the tool OnTask. OnTask was conceived basically to bridge the distance between the existing wealth of data and a very specific element of a learning design, which are support actions, actions to support learning, where by supporting what we mean is anything ranging from suggestions to providing personalized feedback to even put students in contact with other support groups within the institution. OnTask, therefore, is there to make that connection much more intuitive and bringing it all the way down to the level of the instructor. So instructors are the main users of OnTask, and they can, on one hand, connect with data that is being derived from the learning environment, and on the other hand, deploy support actions to their students. The other element that is important to consider the effect of OnTask is that this type of support actions is offered under the assumption that we are addressing a very large number of students. For a small number of students or for small cohorts, those support actions can very likely be done face-to-face. OnTask tries to support instructors with those number of students go in the hundreds or thousands. This illustration captures the overall structure of the tool. At the center of this diagram, what you see is what we call a student matrix or a student table. This table can be thought of simply a regular Excel sheet. Each row in that table contains the information for one student. The columns in the table are the different attributes or observations we consider for the student. To both sides of this table, there are the two main elements of OnTask. On the left side is the possibility to upload and connect with either manually imported data or existing institutional data sources. This is very important as OnTask is data neutral in the sense that it relies on these data sources to be available. But on the other hand, it offers a wide variety of uploading or loading mechanisms to produce or to obtain this data. On the right-hand side, we see the action side. And by those support actions, we just put there a few examples of combining rules to personalize email templates or personalize HTML pages so that the students receive a message or a communication or a support action that is tailored or personalized specifically to their situation. The tool also combines both a web interface and an API, so the data manipulation can be done either as a background process for institutional upload, or the users, in this case the instructors themselves, can drive this process. Let's very quickly focus on the type of support actions. OnTask is built around the notion that feedback is crucial to support learning. There are many factors that affect the way learning occurs, but we have identified feedback as one that is having a very positive effect on how students learn. OnTask is basically allowing instructors to manage what we call workflows. And a workflow is nothing more than a data table, like the one you see in the screen, combined with a set of actions. And these actions are the important pieces. The table is the one that I described before, in which each row has information for one student. The actions, on the other hand, is when we want to provide some sort of communication or information that is personalized to a student. In this screen, you can see at the bottom the type of actions that are currently supported by OnTask. The basic ones are personalized text, and this personalized text could be framed in terms of, for example, a set of badges that are either assigned or not, or they appear or not depending on the results or the data available to the platform. A personalized email in which each student receives a different type of message depending on the way they have participated or the way they have interacted in the context of a learning design. It could be personalized feedback depending or based on a rubric. If an instructor creates a rubric that typically has different aspects that are evaluated and different levels of attainment, the instructors can then create feedback for each level of attainment and each aspect observing the assignment. And that personalized feedback can be then automatically put together and sent to hundreds of students. But the platform also adds some additional support actions that do not directly put them in communication with the students, but they support other actions through the institution, like, for example, sending an email report to a different structure within the institution, or even sending a JSON object, which opens the door for OnTask to communicate with other existing platforms that are members of the technology ecosystem within an educational institution. This screen here shows one example of the email template or the support actions to communicate with the students. And as you can see, it's fairly straightforward. It basically uses placeholders to personalize the name, but more importantly, in the tab that is called text conditions, it allows you to define certain conditions that will control if a message appears or not, depending on the value of certain variables. In this example, we are considering the appearance or not appearance of certain paragraphs, depending on the engagement that the students have had with previously published videos. The platform also allows you to preview those actions for each of the students and allows you to cycle through them, visualize the values that are controlling the personalization of that template, and also the conditions that are being considered in there. So in this example, at the bottom, we can see the values of those variables that are part of the table for the student, but also the value of the conditions that are used to personalize that template. So this basically summarizes OnTask from the angle of the support actions. But perhaps the most relevant one is from the point of view of which data is available and how can that data be uploaded. In its current version, OnTask offered two types of uploads. The first one is manually through conventional data formats like CSV or Excel. And in the latest versions, we have expanded this functionality to be able to load data from Google Sheets, existing Google Sheet, an Amazon S3 bucket in CSV format, or any arbitrary SQL connection. In the upcoming versions, we are already prototyping the access to existing databases in the cloud through, for example, the Athena interface provided by Amazon. Another crucial aspect of data management that has been substantially extended over the last 2 years is the possibility to execute models and transformations. By models, what we understand are models have been previously created and encoded in existing plugins. The platform is sensitive to the installation of those plugins, and as soon as they are detected and activated or enabled by the administrator, these models are available for instructors to execute. So the screen, for example, shows the possibility of having a linear model that has been previously created, let's say, for example, to estimate the performance on a final exam, and execute that model and create within OnTask an estimated result, which then itself can be used to personalize the type of actions we just described before. The other very important element of the platform is the possibility of performing all these data uploading without any intervention by the instructors. What we are referring to here is a fairly comprehensive API that allows us to manipulate the main element of this paradigm, which is the table. So OnTask's API currently offers the possibility of creating, updating, deleting, and managing the tables for each one of the workflows. And given the current internal representation, it allows actually two sets of API calls, ones that are exchanging information through simple JSON objects, and another one that is a bit more precise and preserves a few more additional values that relies on the internal representation of data frames within Python. So after these two overviews of both the actions and the data manipulation, we now provide a very quick overview of the internals of the architecture. The technology stack that is currently used relies on Django as the main platform. Django received the petitions through a conventional web server, conventional as in, for example, Apache, and it uses WSGI to then feed all these requests to the Python 3 engine. Django offers numerous out-of-the-box features that are used within the platform, like, for example, the use of middleware for authentication, a router to select the right pages, but perhaps more importantly, it offers a very tight integration with existing state-of-the-art data analytic packages, like, for example, Pandas, NumPy, and others. The other big element in the architecture is the possibility to use persistent storage through a PostgreSQL database using the ORM layer in Django, which is very powerful, as it offers not only a powerful abstraction of the data stored in the database, but it also offers a very efficient way of manipulating through scripts and even asynchronously through some interactive tools. The other element of the architecture is the possibility to execute tasks asynchronously, like, for example, the massive send of emails that need to be derived when executing a support action. This type of functionality is passed through a message queue system to the platform Celery, which has a set of workers that are the ones that are performing all these applications. So from the point of view of the user, when an instructor has, let's say, for example, a class of 1,000 students and an email has to go out to all those students, the platform will prepare the template, will prepare the conditions, will allow instructors to craft that message carefully, and then the overall task of sending those 1,000 emails is passed to through the queue to the worker, and it's done asynchronously. In summary, OnTask is basically a tool that is LMS agnostic, that is mindful of the existing ecosystem of tools typical in an educational institution, and is addressing a very simple issue, which is retention and student satisfaction. We have run pilots in the past in which we detected how students increase their level of satisfaction with the course because they receive these personalized messages from the expert, from the instructor. This communication being personalized is at the base of this improvement that we're after when addressing retention. And like we mentioned before, the personalization is based on the amount of data that is collected. In a sense, the tool provides a trade-off between the amount of data we have available and the capacity instructors have to provide much more personalized support and make that support scalable. Another way we look at it is we are basically conceiving OnTask as a scalable coach or a scalable platform that allows instructors to perform activities to support coaching. The project is currently open source and can be accessed in the URL you see at the bottom of the screen, ontasklearning.org, and it has been deployed and it's being used in numerous institutions across the world. That's it. I'd like to thank the Open Apereo conference for their opportunity to disseminate this project, and I will be happy to connect with any of you that is interested through the various channels that you can find in these slides. Thank you.